So we're returning to the topics related to dynamic memory allocation by our structure, and let's explore what kind of new changes we are going to have. So the internal set of variables will remain the same, I suppose, but what we're going to do now is that we're going to use a setName function to provide a deep copy of the text which is used outside of the rectangle. So the new version of setName is going to be organized like this. So this is the version of setName. So before, we just accepted pointer to characters that was given to us and remembered this pointer inside of our structure. But this time, or any time that somebody is going to set name for this rectangle, what we're going to do is, in the first place, let's just copy and paste this and discuss the new implementation of setName. So I'll just replace what we have with the new version, like this. So if this is our object, okay, and this is our object, and it contains these variables, and of course, if this rectangle contains pointer to its name, it's pointing to some memory. Right? So this is pointer to a string of characters with the name of our rectangle. Okay, so here's the name, actual characters, and we store only pointer inside of our object. So if this is somehow dynamically allocated memory, which means that this is memory allocated by our program. In fact, it's memory allocated by our structure, a rectangle. Then the first order of business is going to say that if this pointer, okay, contains something that is not a null pointer, so this is a pointer to a real addresses in memory, we're going to delete, and notice the square bracket notation of this pointer. And basically right here, we're asking C++ memory manager to go ahead and delete this memory from our program. So delete will deallocate previously allocated dynamic memory. The next thing is that we're going to find out, and this is the new name. I think it changes to pointer name, right? So this is now PTR name. And we're basically finding out that we're given some other example of memory through this pointer. And what we're saying is that let's find out what is the length of this memory in characters. So we're going to find out how long this is. Let's say it's 32 characters long, just as an example. So the length of the name becomes 32. So we compute this length first. And then we're going to use this new operator, which we discussed in the previous slide, that we're going to create a brand new block of characters of this length. Okay, and so just allocate brand new block of characters of this length, like this. And we're going to call a string copy, str_n copy, which basically copies this many characters from here to here. So all of these characters are going to be copied to brand new allocated memory. And look, this brand new memory is already set to be used by our object. And so first of all, we allocate this brand new memory. Okay, and then we set pointer to point to this memory, and we copy all 32 characters over here, or whatever the number of characters is in the parameter that was given to set name. And in the end, we just the set name just updated our object in such a way that some other block of characters, if it ever existed, is now deleted and returned back to the system, and brand new set of characters with brand new name is now allocated dynamically, and the pointer inside of our rectangle object is now pointing to this brand new memory. So this is the idea behind this new version of setName, and it's checking whether the pointer name is not a null pointer in this if statement. And so notice that the new versions of constructors of our rectangle now are going to look like this. We're going to initialize the pointer with null pointer to begin with, like this, right? So we're just going to initialize it with null pointer, and then in the body of our constructor we're going to say for instance, for the default constructor that takes no parameters to construct the object, we're going to say setName, and we're going to call this rectangle unit, because this is like 1-by-1 rectangle unit. And in the case of the second version of the constructor that we have right here, right? So the second version of the constructor that takes width, height, and the name, what we're going to do here is instead of this old implementation, we're going to call setName, which is our own function, and this time we're of course going to pass the name given to us by the user. So we're going to make a copy. Remember, setName will make a copy of this string of characters. First, it will dynamically allocate these characters, then make a copy, and will eventually set this pointer to equal to the new name. And for efficiency reasons, I just initialize pointer with null pointer to begin with, and inside setName, right, I first check whether this pointer to name is not null. If it's not null, I will delete the old characters, and under all circumstances we just reallocate this pointer to say, give us the new operator is asking the operating system to allocate memory dynamically for us. This is how many characters we want, and of course those will be characters. We want a block of characters. Now the last thing to discuss inside the setName is this +1. Every time I have any sort of situation where I see +1 or -1, it's normally has to do something with boundaries of the memory block or array of elements. So typically this deserves a good comment, and in our case +1, because we need space for a null terminating character at the end of dynamically allocated string. Okay, so this is explanation why we have +1. So let's talk about this. So we have the setName. So once again, when setName executes, it measures the size of, and by the way, let me first change this to be ptr name. So this is the actual modified parameter right here. So according to our handout, I'm just going to be consistent with the handout name right here. So anyway, right here, we're given some sort of prototype of a string, right? setName receives a prototype of the string, and setName is no longer going to use this prototype as as the string that it wants to store inside of our object. Instead, it calls strlen of the length of this string. It knows that this is a string of characters, and we call string length. But every primitive string in C and C++ contains at the end a 0 character. In the character with all bits in its encoding set to 0. It's called a null, right? Null or a null character, or a 0 terminating character at the end of the string. So strlen returns the size of the text, the actual length of characters without the terminating character, right? So for instance, if we have string that looks like this, A, B, C, okay? So this is a string literal, for instance, that was given to this function setName to use. We know that there is invisible, but it's always present, the null terminating character. So typically expressed as like single quotes with backslash and 0 in its notation. But it's present right here. It's always present in here. And when we call C library function strlen to find out what is the length of this string, it will return 3, right? That this string is 3 characters long. It does not include the 0 terminating character. But when we want to make a copy, of course, we want to allocate brand new block of memory like this and provide space for the null terminating character. And this is why we use +1. So if this string length is 3 characters, we still need to allocate 1 extra character when we make dynamic memory allocation. And here we use strncopy, which copies this many characters from the original string. So it will copy characters A, right? Characters A, B, and C. Okay, A, B, and C. And the null terminating character is not going to be included in this memory. I actually need to look up documentation for strncopy, whether it's, I don't think it's automatically appends the null terminating character. So this is why I am suspecting that we also need to set the last character here, the last character, which is the character at index length, equal null terminating character. I think we need this to keep it bug free. So it's interesting that we had this discussion, and I think I need to update the slide to include this line here as well, right? Just here. Make sure we can use this comment at the top right above this line. Make sure that the string is null terminated, right? Null terminated. Okay, so we add this null terminating character. So this is now the new version of setName, which is capable of making a copy of the original string. So this this new operator is now making our rectangle an object which dynamically manages memory. So when we use the setName, it manages the memory dynamically because it's using the new operator, and it always uses dynamic memory allocation. And that includes the new version of our constructors, because to begin with, we set this pointer to null pointer, which is the pointer that's set to all zeros. All bits of this pointer are set to 0, so it's an invalid pointer. But it's predictable and intentional, because right here in setName we always check whether the old name existed. All right, so then we delete and deallocate the old memory block, and then we proceed with the rest of brand new memory allocation and copying. But right here, we just make sure that every time we manage new name, we always call function set name, which is our own member function.